Welcome to Cambridge IGCSE Physics, Lesson 33.1, Production of Sound. Today we explore how sound is created through vibrating sources, understanding the fundamental physics principles that govern sound production in our everyday world. Let's examine our learning objectives for today. By the end of this lesson, you'll be able to, first, describe production of sound by vibrating sources, explaining the physical mechanism. Second, understand sound requires vibration, recognizing this fundamental principle. Third, give examples of sound sources from everyday life. These objectives align with Cambridge IGCSE assessment objectives. AO1 for scientific knowledge, AO2 for application skills, and AO3 for experimental understanding. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, sound production, which means creation of sound waves through vibration of matter. Second, vibrating sources, which means objects that move back and forth rapidly, creating disturbances in surrounding medium. Third, vibration, which means rapid oscillatory motion about an equilibrium position. Understanding these terms precisely is crucial for Cambridge IGCSE success. Let's explore our first core concept. The fundamental principle states that all sound originates from vibrating objects. This means every sound you hear comes from something moving back and forth rapidly. The definition is, sound is produced when objects vibrate, creating pressure variations in the surrounding medium. Key points to remember. First, no vibration equals no sound. This is absolute. Second, vibration creates compression and rarefaction in the medium. Third, a medium is required for sound transmission. The diagram illustrates a tuning fork vibrating. Notice how the prongs move outward and inward, creating sound waves in the air. This principle is fundamental because it explains all sound production. Now we examine the experimental method. This follows Cambridge IGCSE standards. The apparatus needed includes tuning fork made of metal, rubber hammer for striking, and table surface for support. The method consists of these steps. First, strike the tuning fork gently with the rubber hammer. Second, observe the vibration of the prongs carefully. Third, listen to the sound produced. Fourth, notice when vibration stops, sound stops too. Safety is paramount. The hazards include potential injury from sharp edges. Therefore, you must handle apparatus carefully and avoid excessive force. The diagram shows the experimental setup with tuning fork on table surface and rubber hammer ready to strike. Let's work through our first example. The problem states, a guitar string vibrates at frequency 440 Hz. Explain how this produces sound. We are given frequency equals 440 Hz, where Hz means vibrations per second. We need to find explanation of sound production mechanism. Step 1, the string vibrates back and forth 440 times per second. Step 2, this vibration pushes and pulls surrounding air molecules alternately. Step 3, this creates alternating compressions and rarefactions in the air. Step 4. These sound waves travel through air to reach our ears. The answer is, the vibrating string creates pressure waves in air, producing sound that we can hear. Example 2 applies the same principle to different sources. The problem is, identify vibrating parts in common sound sources. Now we analyze systematically. First, in a drum, the stretched membrane vibrates when struck, creating sound waves. Second, in a bell, the metal body vibrates when hit, producing ringing sound. Third, in a whistle, the air column inside vibrates when air is blown through. Fourth, in human voice, the vocal cords vibrate as air passes through. The pattern shows all sources have a vibrating component. The diagram illustrates each source with red arrows showing vibration direction. This demonstrates the universal principle that sound requires vibration. Mathematical skills are crucial in physics. Let's examine 3 key skills. First, frequency definition. Frequency, symbol F, equals the number of vibrations per second. The unit is Hertz, symbol Hz, where 1 Hertz equals 1 vibration per second. Second, period calculation. Period, symbol T, equals the time for 1 complete vibration. The relationship is T equals 1 divided by F, where T is in seconds and F is in Hertz. Third, unit conversion. 1 kilohertz equals 1000 Hertz. 1 megahertz equals 1 million Hertz. These conversions are essential for solving problems involving different frequency ranges. Now practice what you've learned with these three questions. Question 1 is basic level. It asks, name the vibrating part in a piano. Think about what moves when you press a key. Question 2 is intermediate. It states, calculate period if frequency is 50 Hz. This requires you to apply the mathematical relationship we learned. Question 3 is advanced. The question is, explain why sound cannot travel through vacuum. This tests your understanding of sound production principles. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how today's concepts apply in practice. In technology, speakers use vibrating cones to produce sound waves, converting electrical signals into mechanical vibrations and then into sound. In medicine, ultrasound uses high-frequency vibrations above human hearing range for medical imaging, allowing doctors to see inside the body safely. In engineering, vibration analysis prevents structural failure by identifying dangerous resonant frequencies in buildings and bridges. These applications show why physics matters. Career-wise, physics knowledge leads to acoustical engineering designing concert halls, audio technology developing sound systems, and medical physics using sound for diagnosis and treatment. Let's review the solutions. For question 1, the answer is piano strings vibrate when struck by hammers. The strings are the vibrating source that creates sound waves. For question 2, we use T equals 1 divided by F. Substituting T equals 1 divided by 50 equals 0.02 seconds. For question 3, vacuum has no medium. Sound requires particles to transfer vibrations, but vacuum contains no particles, so sound cannot travel. Now, exam success tips. First, always show you're working. Even if the final answer is wrong, you earn marks for correct method. Second, include units in every step. Third, check reasonableness. Does your answer make physical sense? Fourth, read questions carefully. Command words tell you what to do. Let's summarize today's lesson. The key points to remember are, first, the fundamental principle that all sound originates from vibrating sources. No vibration means no sound. This is absolute. Second, the mechanism whereby vibration creates pressure waves in the surrounding medium, forming compressions and rarefactions. Third, examples showing that strings, membranes, and air columns all vibrate to produce sound. For further study, review vibration examples from everyday life to reinforce understanding. Practice frequency and period calculations using the relationship T equals 1 divided by F. The next lesson covers sound transmission, which builds on today's work by exploring how sound waves travel through different media. Ensure you understand vibration principles before moving forward.